In this video I'm going to have a look at chapter 2 of this book, so the exercise that corresponds to chapter 2 of this book, and here I show the content of this chapter 2. I'm going to set up a simulation and check the normal stress in this SolidWorks simulation, which is a pretty straightforward, convenient way of showing how a SolidWorks simulation works. So I'll create a new simulation study in this part. I've started this part with the template that I've set up as shown in the video on chapter 1. So if you want to have more information on that, check that video. So I'm going to create a new simulation study and create a static study. And material is already taken into account because it was entered in SolidWorks. If it wasn't, you can still enter the material over here. So now I'll create a fixed geometry on this surface, which will prevent this whole surface from moving, and I'll create a force on the surface over here that's in the reverse direction and 1000 Newton. And since I'm using the template as shown in the video on chapter 1, I can press the space bar and then change back to my preferred view like this, and now I can run the study. So this surface is completely fixed. I can run the study, and here I see the results. So I've got now the von Mises stress. I want to see the normal stress, so I'll define a new stress plot, and I'll choose the x normal stress, which corresponds to this coordinate over here. So I've got now the stress in the x direction. It's 2.9 Newton per square millimeter, which is pretty low compared to the tensile stress of steel, for example. And if I want to change the setting of this plot, for example, not show it in these scientific numbers, I can use, for example, floating. So I can see the stress in Newton per square millimeter in the x direction over here right now, and it's roughly, on the blue color I can see, it's roughly 2 Newton per square millimeter, except for in this area there's a stress concentration over here. It's happening in this case due to the Poisson's effect. So if I don't want to see the stress concentration, I can do it in two ways. I can create a split line over here, divide the surface, and then set up the fixtures in a way that will prevent this stress concentration from happening. Another way of doing it is changing this fixture. So I can change it in a way that it's not fully fixing the surface, but only fixing the surface in the x direction. So I'll fix this surface in this direction, the same surface I'm going to use, and with this arrow I can then say I only want that movement to be prevented from happening. So the x movement is now prevented from happening, and when I run this simulation right now, some strange things will happen. You see that the part is moving slightly. It's because it's not fixed in the y and x direction at this point, and if I want to change that, I can do it by fixing, for example, one point so it doesn't move. So fixing one point and keeping the other restraint the same. Or another option is to use the SolidWorks Simulation soft springs to stabilize the model, so it does not move in a direction that is not preventing from moving by restraints. So if I run the simulation right now, I see a very uniform display, a very uniform display of stresses. There's a very small variation over here. You can see it's rounding errors in SolidWorks Simulation. They're very small, and if I don't want to have that, if I don't want to see it, I can just change the scale, for example, from 2 to from 1, for example, to 2, and then I'll see a completely uniform color in the whole part because it's a 1.8 is the stress in x direction. So because the Poisson's effect is not happening at this point in time anymore in this part, there's no stress concentration on the left side, which is what is also discussed in the second chapter of this book. So with that, I want to end this video.